really late last night making them, finished them this morning with the solution, so that they're ready to go. So, obviously I did not get to actually updating the agenda. There's Mr. Hobby. But we're doing this mathematic task to help us understand higher power functions, right? So, what was the highest power really on the last unit test? Which one? Degree what? 3. Yeah, cubic, sorry. I kept hearing degree, like slightly saying something like this. But cubic, we're moving into 4th and 5th degree. What card did you have yesterday?
King.
So Shadidra, I'm going to go out on a limb and say you were not supposed to be a king. So I'm going to go out on a limb and say you're probably not supposed to be a king because Brianna was supposed to be a king.
Oh, I'm sorry.
Why don't you join the 9s over here? Alright. Sorry, there was some confusion for Shadidra about what group she was in. Alright. Before we get started though, and also please notice the whole task is all about understanding, and so don't lose sight of the point of what we're trying to do. We're trying to understand how many intercepts, how many extrema, and how many, or what the end behavior would be of a function if I just look at the standard form, okay? So it's making predictions to each of the 9s.
Oh.
9s. So, let me pull this down. We talked about this yesterday, a few of these things, right? Degree we've been talking about for a while. In standard form, what's our degree? In standard form, what's our degree? Like right here, what would our degree be?
The height.
So this would be degree 6. What would be the leading coefficient here?
Negative.
-1, right? Like negative without number means it's -1. So degree, leading coefficient. Now, does the leading coefficient have to be at the front of the equation, or the expression? No. Where's that leading coefficient always located? With the highest power, right? With that degree, right? So whatever term has the highest power, that's where your leading coefficient is. Don't forget that. We have polynomial functions and forms. We have domain and range, zeros, roots, and x-intercepts. And that all-important fundamental theorem of algebra that has not gone away, will not go away, still super important. Keep those things in mind. In the Frere models that Mr. Hobby just printed out, their multiplying factors determine standard form is actually one of the first things there, because we've done that with lower degree functions. You think it's going to change when it gets to a 4th and 5th degree when we multiply those factors out? So you already know how to do this, so it's just a little bit of practice in there. Make sure you're practicing those things. And what I saw yesterday for a few of us is that we're forgetting a little bit of how to solve quadratic equations. You can't forget that. By the way, I do want to remind us all, because I saw a lot of us, several of us trying to solve this equation. Could I use the quadratic formula here?
No.
I could. Why were you thinking you couldn't, Landon?
You don't have just one X. You don't have a B.
So would that prevent me from using the quadratic formula? Well, okay, I see what you're saying. If it's not shown though, what could we assume B is? 0, right? So could I solve this using the quadratic formula? Yeah, so I can still solve it, right? Anytime it's a standard form, I can use the quadratic formula, but what would have been way more efficient in this case? Do I have a product of things?
-6.
Let's see, how many times do I see my variable, guys? Once. It's a type of vertex form. Now, what is the next inverse I would need to use? What undoes that square? Do not forget the inverse of a square is a square root. That would have made one of those problems yesterday significantly easier. How would I factor that -16 to be able to simplify it?
4 and 4.
I could do 4 and 4. I would have just done 16 and -1. 4 and 4 would work. But what's the square root of 16? 4. Okay. So, could have done that. Landon, you are right that I could have done 4 and 4. But remember, if it's already a perfect square, you don't have to do any more. It would have worked out though. 2 times 2 is 4 times I, right? Would have worked out exactly the same way. As long as you're factoring into perfect squares, you'll be fine. All right. But our target, that's a little bit of a recap, making sure we're all good there. The target, though, is just if I look at a polynomial equation, how many x-intercepts could it have? How many extrema could it have? And by the way, when I say extrema, what do I mean? What's the other term we've used? Maximum and minimum, right? So extrema, maximum and minimum, by using the degree, figuring out what is in behavior, and I'm going to bring this back over to what we ended on yesterday to help give y'all a little bit of a recap. The second one is essentially the same thing, but what we're focusing on today is when we start with a what? Equation. This is all about starting with a table, graph, or the characteristics. The fact of the matter is, though, you can start in either way. They are 100% connected, but these are slightly different skills, which is why I put them in 2 different proficiency scales. But that means what we do today is going to drastically impact your understanding of these ideas, and so we got to build those connections. Now, we already talked about this lesson about in behavior, but also extrema, all that stuff. You're going to go to your groups in a second, but I want to remind y'all of this that I already did yesterday. So, did I magically know where this parabola came from? No, what did I do to get it?
Work it out.
I what?
Work it out.
I worked it out.
Put it in the calculator.
I put it in the calculator, right? I graphed it in the calculator. And then I used the calculator to find these features. Please do pay attention. If you're graphing these functions by hand, what are a few key points that you should definitely make sure you have? Your roots, your zeros, okay? So those x-intercepts. And so I will say this, when you go to graph this, make sure your x-intercepts are 100% accurate. Or at least really close to being accurate, okay? I'm not going to sweat right now if your extrema are 100% accurate, but they do need to, you need to have the right positives in the right spot, the right negatives in the right spot, and have extrema relatively making sense. Because I don't think, does the sheet actually ask you to find what the extrema are? It just says how many, doesn't it? How many terms? Okay? So, oh yeah, I literally have examples here. So you need to know your x-intercepts. You just need to have a general sketch around those things. But please do not forget this right here for our end behavior. This is our proper notation that we need to start to work towards. Like the end behavior either goes up or it goes down, and it goes on either side, right? But if it's going up, what is y approaching? Infinity. If it's going down, y is going towards negative infinity, right? This one was both positive infinity, okay? But you have a left-hand side, which I always mark with LHS. Right-hand side, which is RHS, right? I was like, why does LHS sound familiar? That was the abbreviation from my high school. I was like, that's really weird. Lamp High School. Anyways, and we chanted that all the time at basketball games. So, left-hand side, if we're going to the left, what is x going towards? If you're going left, x is going to negative infinity. If it's going right, what is x going towards? Okay, so that's just to help set up so that we can get our information. What I need you to make sure you do quickly and efficiently is work with each other to just get this information up here. So what I did is I want you to put your graph on the white book, and then I want you to put your details on the space next to it, okay? I didn't have a ton of space over there, so I put it all on the white book. So graph goes on the white book, your answers go on the space next to it. Are we clear on that? What are your questions about what we are doing? Ready, set, go! Oh, I screwed up. Davian, I'm so sorry.
I was finna say.
I even looked at it and I was like, oh, Hero Friday. Guys, Davian is doing Hero Friday today. Let me forget this. Davian, get us going.
Okay. My hero is my dad because he's a hardworking man. He loves what he do and he just enjoys life. And I get that from him because I love life and I live life to the fullest. I love working hard too. It's
Because of your dad.
Yeah.
I appreciate that. Thanks for sharing that with us. Awesome. All right. Now let's go do some fun math. Let's work hard, right? Okay. So if I can get y'all to come into the center of the room, there's a couple of small corrections, Mr. Hobby. If you can look around the room, see if there's anything I'm missing. There's two that I need to talk about, but I think for the most part, we're good to go. But if I can get y'all to come to the center, I just want to talk about a couple of things. So remember, when we talk about F here, right? We talked about the left-hand side and the right-hand side. That's the end behavior idea. So as the graph goes to the left, or as the function goes left and as the function goes to the right, what's happening? So I want to be careful, and notationally, I want to talk about this. Right here, can x ever get equal negative infinity?
No.
Has anyone ever gotten to negative infinity or positive infinity in class? Xander, have you ever gotten to infinity? You never try counting that far? Just try it sometime. Not really. I'm kidding. I'm kidding. You can't. Like, it's the idea of infinity. So I want to caution you. Can x equal 2? I'm not saying in this case. I'm just saying in general. Can an x value equal 2? Yes. Can x equal 3?
Yes.
100?
Yes.
10,000?
Yes.
Okay. What about negative 10,000?
Yes.
So x can equal those numbers, but can x ever equal an infinity? X cannot equal an infinity. So what is the notation that I was using earlier instead of equals? We need to be careful about this. The arrow. Do you remember what I said every time with that arrow? It what? It approaches. As it goes towards, right? As x goes towards negative infinity, y is going towards, not this one. As x is going towards negative infinity, y is going down towards negative infinity, okay? Now, I want you to notice, you've always seen me stack them, right? Like this. Is it okay to say it this way as well, where you just write it horizontally? Yeah, 100%. And so you'll actually see the textbook do this. Typically, you want to put a comma in between, and you put the word as. Just like in English, I know it's going to sound bizarre, but in English, hopefully at some point we talked about dependent clauses. That sound familiar, right? The word as is a subordinate conjunction creating a dependent clause. And this is a mathematical sentence. As x approaches, there's my subject, there's my verb. So as x approaches negative infinity, we have a dependent clause, so I need a comma. So as that happens, what else is happening? Y approaches negative infinity. That's why you always see me put the word as in front, right? It's a sentence. And so, as x what? Approaches what? And as x goes to the right, that's going towards infinity, comma, y approaches infinity. Okay? And so I want you to understand, like, I know there's mathematical symbols in there, but it's still a sentence telling us what's happening. And so we want to be intentional about that. And one thing I will also make a note of is, you don't actually have to write left-hand side and right-hand side. However, writing that makes it really easy for you to look and say, okay, I'm talking about over here versus over here. Okay? That's why I write left-hand side. Because literally, if I tell you x is approaching negative infinity, which side is that? If I tell you x is approaching negative infinity, that's going left, right? So do I need to say left-hand side? No, but that's a good reminder for you to remember left-hand side. Or to remember x goes towards negative infinity. So please take advantage of that. Now, Mr. Javi, did we get the... We just need to fix that notation, right? For
F?
Yeah. That was it, right?
Yeah.
Okay. Can you fix that notation for me real quickly? So with F over there, the 9s, y'all did domain and range. That's perfectly fine. We're not worried about domain and range, right? We just need the as x approaches positive infinity, negative infinity, etc. So, Mr. Hobby, if you can also erase the domain and range just to make that extra room. I think everything else was correct. I'm going to be looking to see if I see any other errors, but I do want to point out with the 8s over there on D, they said the cubic changes direction 2 times. The idea of changing direction is the same as what y'all called what? Or we said what around the room? Turns, right? And don't forget, turns are also our extrema. And so, Notice 1 turn, 2 turns, 3 turns here. And so I want y'all to start to associate that word turn with extrema, because turn is a more casual thing that we probably know. But start to connect that with that word extrema. Wherever there's a turn, there's an extrema. Because literally, what is a relative minimum? That's where the function, what? Stops decreasing and starts to increase. That's a turn, right? That's a minimum. But here's where we got to get to, okay? I have a final white book over here that we're going to talk about and try to generate some ideas. But you each have created a graph with all this information on it. And what I want us to do is we're going to start to now look at number 2 with a gallery walk. So what I want you to do is I want you to go to your white book, but then go 1 to the right, so clockwise. So go 1, start at yours and go clockwise by 1. So the 9s go to 8s, the 8s go to aces, aces to kings, kings to queens, clockwise, like a clock. Huh? Clockwise, from 12 to 1 to 2, etc. So queens are over here to jacks. Okay, so here's what I want us to start to do as we move around the room. You'll notice, and we're only going to do one part at a time, because I tried doing all of it at the same time, and it's way too much. It overloads you. I want us to look at A. A says, how do you determine the maximum number of x-intercepts a polynomial has using the equation? What about the maximum number of turns? So, we're just going to focus on x-intercepts right now. So, I want y'all to look at the equation. Specifically, I want you either thinking about B or E. How does B or how does E inform us? Because B was all about the degree, I think, right? And E was all about the leading coefficient. So those are the things we're focusing on. How does the degree or the leading coefficient inform us how many x-intercepts there could be? All right, so what are we trying to make a prediction about? How many x-intercepts are going to be either using the degree or the leading coefficient?
Yeah, so go that way.
So, I'm going to have y'all rotate every 30 to 45 seconds. Start generating some conversations, asking some questions. So start to investigate. Come up with a prediction. How do you think we can figure out how many x-intercepts there's going to be? To the center of the room, because I want to look at some of these together. Looking around the room, making some predictions. So, x-intercepts. How are we figuring out how many x-intercepts there are? The highest power? What's that highest power also called? The degree. Okay, so we're thinking the degree is telling me about my x-intercepts. So, over here, we have, on the kings, degree 4. Does that mean there's always going to be 4 x-intercepts?
Oh, no. Wait,
Alright, so here's the thing. I need y'all to make an argument. So some of us saying yes, some of us are saying no. Let's hash it out. Let's figure it out. Why do some of us think no? Oh, so we could have double roots. We could have what? Imaginary numbers, right? So that's an interesting idea. So let's see here. I'm going to make something up really quickly. But let's just say I have something like this. Maybe something like this. How many, what degree is this one? 4, okay. How many zeros should it have? 4. But maybe it looks something like this. How many x-intercepts does it have? It only has 1 x-intercept. So how in the world does this have 4 zeros? So how many imaginary roots do you think?
Well, maybe 2.
Okay, so this is a what? A double root. And so it would be how many imaginary?
2.
So I haven't talked about this yet, but I do actually want to point this out and let y'all know this. Imaginary roots always have to come in pairs. You can never have an odd number of them. Because how did we get imaginary roots? Like x squared equals negative 4. Because I got a plus or a minus, right? So imaginary roots always have to come in pairs. You can never, ever, ever have an odd number of imaginary roots. They have to come in pairs. But this one still works because this 1 x-intercept is a double root. So do we still have 4 zeros? Okay, so what we need to recognize here then is, let's work on our language with this. is the degree always the number of x-intercepts? Okay, so the degree is always the number of zeros. Okay, so the degree is always the number of zeros, but the number of x-intercepts could be described how? Well, I'm just talking about the number of x-intercepts. So let me ask this fourth degree, could it have 4 x-intercepts? Yeah. Could it have 3 x-intercepts maybe?
No.
This one doesn't, but what about if I drew it like this? How many x-intercepts does it have now? 3. So could it have 3 x-intercepts? Could it have just 2 x-intercepts? What about 1? Could it have 0? That would also be a fourth degree. We can talk about something in a little bit why that would also be a fourth degree. So could it have 0 x-intercepts? So the degree is not the number of x-intercepts, it's just the what? Say it again. It's the amount of zeros, yes, but yes, I was going to say it this way. Isn't it just the maximum number of x-intercepts? The degree is the maximum number of x-intercepts. The degree is the number of zeros, but because of multiplicity, because of imaginary numbers, it's only the maximum number of x-intercepts. Please write that information down. We're seeing that, but that language is important so we don't forget it, right? So we're seeing, y'all are talking about it, we're noticing this. Make sure you make a note that the degree is just the what number of x-intercepts? Maximum number. It could be less. Very much could be less. Is this in your piece of paper, David? Do what? Okay. Alright. Once you are done with that quick set of notes, go stand by the white book you ended at so we can get moving to the next piece of this. Alright, so on part A, I asked about the number of x-intercepts. What else am I asking about there, though?
Maximum number.
Oh, the maximum number of what? Turns. Or what's another word for those terms? Extrema. Notice I asked about the maximum number of extrema. So what I now want you to start to look at is, look at your equation, okay? Look at the equation and see if there is a pattern to how many turns or extrema there are based on that equation. So you've got 30 seconds of your current board, and then we're going to rotate. So I heard a lot of really, really good conversations, a lot of really good thinking about these things. So Sarah, what was the conversation y'all were having about how to determine the number of extrema?
We thought it was the second highest degree, but then this one over here was confusing us.
Ah, so you thought it was the second highest power, right? So whatever the second term was?
Yeah.
Okay, so yeah, let's look at this one, right? And I'll be honest, I'm so glad that's what you said, because I literally made this question based on that conversation in previous years, so I'm glad that came up. Alright, so what you're thinking is the second term, or the second highest power, which would mean there's how many terms here? There should, based on that logic, there'd be how many terms? There'd be 2 terms, right? That's not 2 terms, is it? Jaden, what were you thinking?
The highest degree, the terms lowest minus about 1 by the highest degree.
Okay, so taking the highest power minus 1, and that would give us how many terms? 3 terms? Okay. Looking over here at this cubic, how many terms would we expect based on that? 2, right? Well, it is cubic, right? To the third? Based on Jaden's conversation, he said the power minus 1, right? Or the degree minus 1, which would be? And how many do you see? 2. That sounds pretty logical, doesn't it? Huh? I don't think I ever told you no. I think I asked some questions to get you thinking some more. What did I actually ask you, Miles?
I don't know.
I don't know. Okay, so looking at these two up here, what power is it? 5, and how many turns then, based on that logic, would we expect?
4.
And does it have 4 turns? Now, I remember what I asked y'all, Miles, is I said, does it have to have a 0 to have a turn? And the answer there was no, right? Because what I heard Landon and Miles' group talking about was that it has to turn between the what? The zeros or the x-intercepts, right? But I mean, we can have imaginary zeros, and there's that. Anyone have a prediction what degree polynomial that would be? Floating there in space? Degree 4? Why do you think degree 4?
Because 4 minus
Because what?
the high power minus 1.
So the highest power minus 1, there's how many turns? 3, and so 4 minus 1 would be that 3, right? So what we're thinking right now, what I'm hearing is that if you take the degree, and notice I keep saying degree instead of highest power, right? Because degree means highest power. So if I take the degree minus 1, that's my number of extrema? Yes? Okay, so Sarah, does that reconcile what y'all were having that issue with? So, and I think Landon even said this, and I was really, really excited to hear Landon say this. He said, well, that 2x to the 4th could just be a 3, but it would still be 4 turns. And he's 100% right. Right? Just because I skipped that 4 doesn't mean that x to the 4th is not there. It's really about the degree minus 1. But I have another one to look at with you. So, this function, based on our conversation so far, how many x-intercepts would I expect that 6th degree to have? 5 x-intercepts. At least, I expect 6 or less, right? That's the maximum. How many extrema would I expect to see? 5. Okay? Uh-oh. It only has how many x-intercepts? It only has 4. How many extrema does it have? It only has 3. Uh-oh. Why is that happening?
Because they did the second high power minus 1.
Say it one more time.
They did the second high power minus 1.
Okay. That's interesting. I wouldn't have thought about it like that, but that's fair. Any other ideas? No other ideas? You scared to have ideas? Yes, Mr. Kenny. Ideas are terrifying. Alright, let me get this sketched really quickly. I meant to already have this sketched, but obviously I failed in that regard. I'm sorry, guys. Alright, so something like this. Alright, so let's talk about something here that I want us to note. Remember how I said, so 1, that n right here, that's what we call our degree. So 6 minus 1 is 5, right? But what does it say on that sheet of paper? Does it say the number of extrema? Or does it use a different phrasing there? Sorry. Does it say the number of turns, or does it say something slightly in front of that number?
Maximum.
The maximum number of turns. So the maximum number of turns is what? Remember the 6th degree. So the maximum number of turns is, so max 5 extrema. All right, cool. But this one has how many? 1, 2, 3 extrema, right? Do you know there's one more option? Not 0. What do you think the pattern is? Not sure? Say again? Minus 2? At least we're there, right? It was just down by 2 each time? Okay. I think I made another one to help me see this. Let me see one thing real quick. I made a whole bunch of these intentionally. Alright, yep, that's what I did. Sweet. All right. So here is what we're about to look at is y equals negative x to the fifth minus 3x to the fourth plus 3x cubed plus 13x squared plus 27x. There's something else in there that I'm missing. Plus 9. And I ran out of room. And all of that is divided by 4. Okay? So, based on that one, how many x-intercepts do we expect to see? I hear 5s and 4s. So, remember, the degree is always the number of what? Not always the number of x-intercepts, the number of what? Zeros, or roots. So that could be the number of x-intercepts, or it could be less. Remember, that's my maximum, right? So it could be 5, 4, 3, 2, or 1. Now, we'll point this out. That one does have to have at least one x-intercept. We're going to talk about why when we talk about in behavior in a second. But how many extrema would we expect to see?
4.
We would expect to see 4, right? How many x-intercepts do we actually have? 3. How many extrema do we actually have? So we expected 4. So we knew there was a max of 4 extrema. But how many are there actually? There's actually 2. Anyone know what the other option could have been for a 5th degree polynomial like this?
None.
Mhm. So what is the pattern for the possible number of extrema for a polynomial? So you find your maximum, right? Which, how do we find maximum again? The maximum number of extrema.
Highest power minus.
What's an easier way to say highest power? Degree minus 1. And then from there, it just goes down by 2's. That's it. That's really important information.
I think we should write it down, guys.
Thank you, Peyton. Awesome. Yeah. So guys, the highest power or degree minus 1 is the how many extrema? The maximum number of extrema. Degree minus 1 is my maximum number of extrema. But they always come in pairs. I think A asked about the maximum number of extrema, doesn't it? It sure does, right? I don't know. What did I say, Miles?
Degree minus 1.
Is the what?
Maximum number.
Maximum number of extrema, right? The degree minus 1 was the maximum number of extrema. But extrema always come in pairs. So it can decrease by 2.
Hold on, can you just write that down somewhere?
No, I'm going to say it one more time.
Please, please.
It's like a saying.
Slow.
The maximum number of extrema is... Sure, you already had that written down, right?
Would that be the
No, that's not
answer?
Well, the x-intercept part and the extrema part, yes. Yes.
The next number.
The maximum number of extrema is the degree minus 1. Uh-huh.
I got that. That's it.
By the way, you know that this information is also up here in a lot of ways, right? Maximum extrema is the degree in minus 1, and then they come in what? Pairs. Always minus 2, right? Always minus 2.
I got it.
Okay.
I was virtual, so it might not be this.
All right. At this point, has anybody already thought about B?
No.
Bet. All right, go back to your vertical surfaces. What I want y'all to do now is I want you to think about what is determining if the end behavior is in the same direction or in different directions. So start at the last vertical surface you were at, the last white book you were at, and I want you to start thinking about what is causing the end behavior to be the same or to be different.
So you going back to the same one?
Want to move that back up?
You've been leaving it recording?
Yeah.
I got a whole lot of people in the back, but I got 2 white folks up here. All right. So we've got some great conversations going on right now. I'm going to take this purple one that I really want to. Huh? Yeah, I might be a hoarder when it comes to markers. I pick a good marker and then I, forget that it's there. All right. So looking at this, talking about this, what I heard some conversations, and I want to bring these out now, is this. So I think there's 2 people that have been talking about the terms. I want to talk about that, right? There's 2 terms here, right? And is the end behavior the same or different? It's different, right? Like 2 terms, the end behavior is different. When we look over at the cortex, right? Remember that's the 4th degree. How many turns are over there? 3 turns, right? And the end behavior is the same. Yeah, cortex, 4th degree. And so that's an interesting connection. When I look over here, quintic, that's the 5th degree, right? How many turns are there? 4 turns. And is the end behavior different or the same? It's different. So I think, Mr. Hobby, you said Demia was seeing this?
Yes.
And I also heard Elizabeth saying this, that if there's an even number of turns, the end behavior is the same. No, is different, sorry. And if it's an odd number, of turns or extrema, the end behavior is the why? You gotta hurt me in this way.
Thanks for that.
Wow, you're trying to destroy Mr. Hobby's stuff?
That's what I'm doing.
Alright, and that seems to hold, but I started to push on this conversation a little bit with a couple of groups. I want us to look at this again. Elizabeth, what was I asking you about?
The degree.
The degree, right? Because I want y'all to pay attention to this. I want you to think about this. If there's an even number of turns, what degree is it? Or what type of degree is it? It's an odd degree. So if it's an odd degree, does the end behavior different every time? Yeah.
Yeah.
We look around the room like if it's an odd degree, the end behavior has been different every single time. And so if it's an odd number of extrema, odd number of turns, what type of degree is that? So if it's an even degree, the end behavior is the same. That is 100% valid based on what we're looking at. I would probably write that down. If it's and so can you look at the number of extrema? 100%. But it's easier to look at the degree, because without graphing it, I see the degree right there. So if it's an odd degree, the end behavior is what? Is different. And if it's an even degree, the end behavior is the same. Which the terms in the extreme, or like the terms in the degree, or why it's the same? Or yeah, why it's the same. Not yet. Yeah. Let's talk about that a little bit more. Alright. Okay? Now, what I want to point out with that is this. That means we actually only have 4 different types of end behavior. They can both be up. They can both be down. And so when I'm looking at this, what type of degree would this be, even or odd? Even degree. This is even degree if the end behaviors are the same. And then one can be down and the other one up. And then up and down. So notice all I've done is put the end behaviors in there because there's infinitely many options in the center here, right? That's an option. Okay? That's an option. What's happening in the center could be anything. What we're just focused on is the end behavior. There's only 4 options for end behavior. That's it. And one thing I will point out is I'm going to start to give you equations, and I'm going to ask you to tell me what the end behavior is just by looking at the equation. Well, first off, if it's even degree, we know it's got to be one of these 2, right? If it's odd degree, we know it's got to be one of these 2. And by just picturing this, I could go, okay, if I can figure out if it's this one, then I know as x goes to negative infinity, so as we go left, what's y doing? It's going down to negative infinity. And so we now know how, sorry, I'm supposed to say odd degree. We now know how to determine if it's even or odd and like what that tells us, but we have not talked about how to figure out if it's this one or this one when it's an even degree. When it's this one versus this one when it's an odd degree. I know Miles has noticed a pattern. Has anybody else already noticed a pattern for when it's like this? Sarah?
When the number is negative. it's
Which
on
number?
The leading coefficient.
When the leading coefficient is negative, it's concave.
Yeah.
Now, one thing I do want to encourage you to remember is that with a parabola, it's concave down, right? But when I look at this cubic over here, is that concave down? Notice it's concave down here, but then it's concave up here. When I come over to this quartic, would I just say that this is concave down? Would I say this is just concave down? So overall, the end behavior is down, right? But notice this is concave down, this is concave up, and this is concave down. So I like that thinking because it's connecting back to the quadratics, but we got to be careful and intentional about this. What is down? The end behavior. Now it's also only down for the end behavior when it's even or odd degree. Because what I would point out is, like, that's overall increasing. That there's another one that's decreasing, but I guess let me rephrase this. Up versus down is only for what kind of degree? Because like when I look over here, this isn't just up, it's not just down, it's this thing, right? So when can we think up versus down? Well, positive, say that one more time. Okay, positive is leading coefficient, but come on. When can I think up versus down? Look around the room, look at all the options. When do I see up versus down versus when is it different? When is it different? Oh, odd degree versus even degree, right? So when it's even degree, we can think up versus down. Does that make sense, Sarah, based on that logic? So, using all that information, up versus down is even degree. When's it going up? Not necessarily. It's based on what Sarah's saying. Sarah, you were saying it's concave what?
For what?
Here, you're talking about concave down when what?
When the leading coefficient is negative.
So leading coefficient is negative. Is it down? Over there, the negative x to the 6th, right? That leading coefficient, is it negative? Is it also going down? Yes? Okay, so so I'll point this out. What letter have I shown y'all to use for degree? N, okay? When we talk about leading coefficient, we usually use the letter A.
Can we please have Isabella Stover to the office really quickly?
She's on her way. So we usually use A for leading coefficient. So this is when A is what? Negative or less than. What do we have to be less than to be negative? Less than 0, right? So if my leading coefficient is negative, it's going to go down, okay? So what's the case when it's going up like this?
If it's
A is greater than 0, or that leading coefficient is positive. Okay, has anybody figured it out for the odds yet, though? Miles? Yeah. You did. Because you talked to me about it over there.
It's about, like, I forgot what I said, oh my God. It was about the negatives and the positives.
There's something about the negatives and positives. Negative and positive what? Leading coefficient. Remember, you wanted to push back on the drawing over there for the aces. What did you want to push back on? Can you go over there and show? And I'm glad Miles knows this because I missed this detail. We got to pay, and my guess is that group just put in or missed the negative when typing the equation in. But what did you notice, Miles?
Oh, it's a negative A
And it's going up, right? So it's got that negative leading coefficient. So Miles was thinking it needed to go down on the right-hand side. So notice right here, is this leading coefficient positive or negative? And notice how it's going up, okay? I do want to point this out because this is the easiest way for me to have ever learned how to see it. Remember, does anyone remember what the simplest odd degree polynomial there is?
What?
The simplest odd degree polynomial there is. It's linear. First degree, right? I want you to think about this. If I were to draw a line through here, is that slope positive or negative?
3. Positive.
That's a positive slope, right? So when we have a positive slope, it's increasing from left to right. So looking back to here, when it's down on the left-hand side and up on the right-hand side, that leading coefficient needs to be what? Think about a line, that A is positive. And if it's overall decreasing, what's my leading coefficient? Leading coefficient is negative. Okay. So now, if I give you an equation, you can just look to see what the end behavior is. Remember, every even degree, you can think about it like a parabola, because the inside doesn't matter. What's the only thing that matters? The inside doesn't matter. All that matters is what are these called? Ends, right? The end behavior. If I'm asking about end behavior, the inside doesn't matter, just the end behavior does. And these are the only possible end behaviors. So if it's even, it's going up together or going down together, and it's determined by positive or negative. If it's odd degree, think about it like a line. And if it's a positive leading coefficient, it's increasing. If it's a negative leading coefficient, it's decreasing, like a negative slope. I think that's all I had for you on those lessons. Make sure, guys, that you get these notes about that end behavior on there. So remember, these are always even degrees. These are always odd degrees. Notice I did also make it so these are always my positive leading coefficients. These are always my negative, but connected to parabolas and linears, and we have not passed out the Frere models. No. I'll give it to him on Monday.
Oh my God, it's Friday. I'm gonna go to sleep.
I'll just give it to him on Monday. I haven't really done enough practice for them to really start practicing.
I'm trying to find a job.